Okay, welcome back, students. Let's go over trigonometric identities. 5.3, 5.4, sum and difference identities. So sum and difference identities, they turn addition into multiplication. So the sine of a plus b is equal to the sine of a times cosine b plus the cosine a sine b. Sine of a minus b is equal to the sine of a cosine b minus cosine a sine b. The cosine of a plus b is the cosine a cosine b minus sine a sine b. Cosine a minus b is equal to cosine a cosine b plus sine a sine b. The tangent of a plus b is equal to the tangent of a plus tangent of b all over 1 minus tangent of a times tangent of b. And the tangent of a minus b is equal to the tangent of a minus tangent of b all over 1 plus the tangent of a times the tangent of b. So you can see that there's some relationship between the signs here. So sine of a plus b is a positive, it's a positive, it's positive, plus sign, plus sign. The sine of a minus b is minus. The cosine of a plus b minus, and the cosine of a minus b plus. So the signs have the same sign, pun intended, and the cosine has opposite sign. The tangent has the same sign on top, but opposite on bottom, and that's true for both tangent sum and difference identities. Okay, note, these identities may be used in finding exact trig values of numbers that can be written as the sum and difference of two special numbers. For example, find the sine of 7 pi over 12. So this may not be completely obvious, but 7 pi over 12 is, I believe it's 75 degrees. So we could go 7 pi over 12 times 180 over pi, right? And that cancels. And then this 12 goes into 180. What is that going to? 15 times, I think. 15 times. Yep. So 12, 180 is 15. 15 times 7 is, 75. Oh no, sorry, that's 105. Not 75, it's 105 degrees. Okay, so we want the sine value of this guy, which is 105 degrees. Okay, 7 pi over 12. Okay, so how can we rewrite that with some special angles? Well, let me think about that for a second. $60 plus 45, would that be good? I think so. 60 plus 45 would work. So this is going to be the sine of 60 degrees plus the sine of 45 degrees. Okay. The other way to think about this is that this is the sine of pi over 3 plus pi over 4, and then you would get a common denominator of 12. And so you would end up with 4 pi over 12 and 3 pi over 12. Excuse me. 3 pi over 12, which would end up your 7 pi over 12. So this works. So we want the sine of being the addition formula for sine. Well, that's the first one. So this is going to become sine of 60 times the sine of 45 plus the cosine of 60. Oops, no, times the cosine of 45. Sorry. Times the cosine of 45 plus the cosine of 60 times the sine of 45. Okay. So this is going to be equal to the sine of 60 is radical 3 over 2, I believe. And the cosine of 45 is radical 2 over 2. Okay. And then we're going to add to that the cosine of 60, which is 1/2. And then the sine of 45, which is radical 2/2. So this becomes radical 3/2, radical 3 times radical 2, which is radical 6/2, plus radical 2/2, which, or sorry, this is over 4, my bad, plus radical 6/4 plus radical 2/4, which is equal to radical 6 plus radical 2 all over the common denominator 4. Okay, so that's what the sine of 105 is. Okay, what about the cosine of -75? Well, the cosine of -75 is really the same as the cosine of +75 because it's an even function. And then we're going to do something very similar to what we did there. It's going to be the cosine of 30 degrees plus 45 degrees this time. Okay, and then that's going to be equal to what? It's going to be equal to the cosine, the cosine of A cosine B. So it's just the cosines multiplied minus the sines. So cosine of 30 degrees, cosine 45 degrees minus the sine of 30 degrees, sine of 45 degrees. Okay, cosine of 30 degrees, that guy is the xy, that's radical 3/2 again. So yeah, so this is radical 3/2. This is radical 2/2 minus, this is going to be 1/2 times radical 2/2. So it really is the same thing we got above, except it's going to be a subtraction symbol. So this is really radical 6 minus radical 2 all over 4 when we go to simplify that. Okay, the cosine of 173, cosine of 83. So we've got cosine, cosine plus sine, sine. So working backwards, I think it's going to be this one here, cosine A minus cosine B. So cosine of 173 minus 83, that's the cosine of 90 degrees, which is equal to 0. Okay, so nice. Okay, note, these identities are used to rewrite expressions as trig functions of a single variable alone, are also used to rewrite these as trig functions of a single variable. Okay, so write cosine of 180 plus theta as a trig function. Okay, so using the identity above, cosine A plus B, this is going to be cosine, cosine minus sine, sine. So cosine of 180 times cosine of theta, is it minus? Yeah, minus sine of 180 times the sine of theta. Okay, so the cosine of 180, I know what that is. That's -1. That's from my unit circle. And the cosine of theta minus the sine of 180 is 0. And that's times the sine of theta. Well, anything that was multiplied by 0 is 0. So this thing just goes away. That whole thing becomes 0. So this is just going to be negative cosine theta. So we could rewrite this as cosine of 180 plus theta. So if I add 180, or if I turn the point one rotation of 180 degrees halfway around the unit circle, then it just becomes negative of whatever the original angle was. So that's kind of interesting. So if I have a point out here on the unit circle, and I were to rotate that 180 degrees, then the cosine value, or the x value, just gets flipped from negative to positive. So no matter where I am, if we were in quadrant 1, we would go to quadrant 3, which would make it from positive to negative. Okay, and the other quadrants work just the same. If I was in quadrant 3 and I wanted to flip 180 degrees, it'd become positive. So where it was negative becomes positive, where it's positive becomes negative. Okay, example 10 here is a kind of big one. Okay, so the cosine of A is equal to negative 7 over 25. The sine of B is equal to negative 3 over 5. Okay, and they're saying that A here is in between pi and 3 pi over 2. That's quadrant 3. Okay, and in quadrant 3, we know that the cosines are negative and the sines are also negative. So the sine of angle A is going to have to be negative. I have to keep that in mind. Okay, angle B is in quadrant 4. Okay, where the cosines are positive, but the sines are negative. Okay, the x's are positive, the y's are negative. And so the sine of B is negative, that makes sense. Okay, but when we go to find the cosine of B, we're going to have to make sure that it's a positive value. Okay, so let's work on the sine of B, sine of A. Let's find the sine of A. Okay, so I have to set up a triangle. This triangle is in the third quadrant, so I'm going to look at it like this. And I know cosine is adjacent over hypotenuse, so this is 7, negative 7, and this is 25. Okay. So I'm going to use Pythagorean theorem here. So negative 7 squared plus b squared is equal to 25 squared. So b squared is equal to, what's 26, 25 minus 49. Okay, that's 7 squared. I moved the 7 squared, negative 7 squared to the other side. 625 minus 49, that is 576. B squared equals 576. So if I take the square root, b is equal to 24. That's cool. That's actually a Pythagorean triple, is 7, 24, 25. Okay, and so what's the sine of A going to be? What's the sine of A? Okay, the sine of A is going to be opposite over hypotenuse. So that's just, and keep in mind that the 24 had to be negative, right? Because remember, this was a plus or minus, and that was a minus 24. It had to be negative. Why'd it have to be negative? Because it's in the third quadrant. So what's the sine going to be? It's going to be negative 7 over, I'm sorry, negative 24 over 25. So negative 24 over 25. So that's the sine of A. So that's a key component for what we want to do here, because we need to know what the sines and cosines are for all of these. So sine of A is a key component. Cosine of A is a key component. So we have those. Okay, now sine of B. So we need to work on the cosine of B. What's the cosine of B going to be? And again, we're going to use the fact that this thing is in the fourth quadrant. So it looks like that. Okay, and sine is opposite over hypotenuse. So the opposite is negative 3. Hypotenuse is always positive, so that's 5. Okay, and so what's the value for the adjacent side going to be? Well, again, Pythagorean triple tells me that I have a 3, 4, 5 right triangle here. So this is 4. Okay, and you could verify that. 3 squared is 9 plus 4 squared is 16. So negative 3 squared plus 4 squared is equal to 5 squared. 9 plus 16 does equal 25. So it does verify. Okay, and is the 4 positive? Yes, the 4 is positive. Why? Because we're in the fourth quadrant. So what's the cosine of B going to be? Well, it's just going to be 4 over 5. So now we have all 4 of our values that we need to find these sum and difference identities. Okay, so the first one that we need is the sine of A minus B is equal to, I believe this is sine A cosine B minus cosine A sine B. Is that right? Let's make sure that one is right. Sine A cosine B minus cosine A sine. Yes, perfect. Okay. Okay, so now what do we want? Well, we just have these values for cosine sine of A and B, and we just multiply them together. So this is negative 24 over 25. The cosine of B we found to be 4 over 5. minus, this is going to be negative 7 over 25. And this guy is going to be negative 3 over 5. So 24 times 4 is 96. So this is 96. 25 times 5 is 125. Oops, 125. Okay, this is 3 negatives. Well, the negative 24 times 4, that's a negative 96. But if we look here, we've got a negative, negative, negative. That's 3 negatives. That's going to make a negative. Okay, and that's just going to be 21 over 125. So I'm going to subtract that. Negative 96 minus 21 is negative 117 over 125. So negative 117 over 125. Okay. So that was the sign of A minus B. Okay, let's try the tangent of, was it A minus B? Tangent of A minus B is equal to tangent A, I believe, let me make sure I can get this correct. Tangent A minus tangent B all over 1 plus tangent A tangent B. Oops, I think that's right. Is that right? Tangent A, yeah, yep. Okay, so again, what is the tangent of A and tangent of B here? Oh, okay. Well, how do we find the tangent of A? Well, tangent of A is going to be sine over cosine, right? So tangent of A is sine over cosine, sine A over cosine A. And the sine A was negative 24 over 25. Cosine A was negative 7 over 25. So the tangent here in the third quadrant is, we could have actually just looked at the triangle. If I highlight the triangle, that might be the easier way to go since we already have it all calculated. The tangent would have been negative 24 over 7, or negative 7, which is just 24 over 7. So that's one way to go about it. Negative 24 over negative 7, but the negatives will cancel each other out. Oops. Okay, 24 over 7. Okay, so, and then if we look at the other one, what's the tangent of B? Okay, maybe I'll just go to the triangle that we made. Okay, the tangent of B is just negative 3 over 4. So yeah, so I don't even have to do the sine or cosine. Negative 3, that's 2 different ways of getting the same answer. Just kind of show you there. Okay, but what's this going to be? This is going to be equal to the tangent of A, which is 24 over 7, minus negative 3 over 4, tangent of B, all over 1 plus 24 over 7. Sorry, my 4s look like my 9s. 24 over 7 times negative 3 over 4. Okay. Okay, so I'm going to add the top here. I'd have to get a common denominator of 28. So I'm going to do some of this arithmetic, in my head or on my calculator. I'm not going to waste a lot of time doing this, but if I were to multiply both top and bottom here by 4, multiply both top and bottom here by 7, I would get a common denominator of 28. Okay, 24 times 4, I think that's 96. Times 4 is 96 minus, and that looks like a negative 21. So it's looking like a 117. Okay, 117 over 28. Okay, 24 times negative 3. What's 24 times negative 3 is negative 72. So I'm getting, I'm going to do 28 over 28 minus or plus negative 72 over 28. So 72 minus 28 I believe, is 44. Yeah, so 72 minus 28, it's 44, yeah. So this is going to become negative. I'll just put it down here. This is going to become, the 28s will cancel. So 117 over 28 all over, that's a 2 right there, all over 44 over 28. 28s are going to go away. This is negative 44. And so we end up with 117 over, negative 117 over 44. Sorry, negative 117 over 44. Okay. Okay, let's look at example 11 here. It says, write the tangent of theta plus 3 pi as a trig function of theta alone. Okay, so tangent of theta plus 3 pi is equal to the tangent of theta plus the tangent of 3 pi, which is really the same as pi. Because once you go around 2 pi, it's really just the tangent of pi. And the tangent of pi is just, tangent of pi is, what is the tangent of pi? Tangent of pi, I believe, is 0. Okay, so, and so then we get 1 minus the tangent of theta times the tangent of 3 pi. Okay. Okay, so yeah, tangent of, let's think about this for a second. Tangent of 3 pi is the same as tangent of pi. And where's pi located? Negative 1, 0, right? So if I go all the way around the circle once, that's 2 pi. And then I go halfway again, that's 3 pi. That's at 0, 1. If I take y over x, that's tangent, which is 0 over negative 1, which is 0. Yeah, so the tangent of 3 pi is 0. Okay, I probably could have just, you know, did the tangent of, what is it, 540, 180 plus 360 is 540. If I plug that in my calculator, tangent of 540 should give me 0, and it does. Okay, so I could verify it on the calculator as well. Okay, either using radians or degree. So tangent of theta plus the tangent of 3 pi. So again, we said that the tangent of 3 pi was 0. So that goes to 0. If this is 0, then the whole bottom is just 1, because tangent of theta times 0. So this just becomes tangent of theta over 1, which is just the tangent of theta. So it didn't matter if I added a pi or not. So, you know, I could rewrite this as the tangent of theta plus 3 pi, which is really like the tangent of theta plus pi, is just equal to the tangent of theta. So again, if I were to take a point and rotate it 180 degrees, okay, rotate that point 180 degrees around the unit circle, I would then, the value of tangent stays the same. So if I go from the 4th quadrant to the 2nd quadrant, or from the 1st quadrant to the 3rd quadrant, or vice versa, I end up having the exact same tangent value. So that's kind of cool. Okay, let's verify that the identity is, that the equation is an identity here. Okay, so we have tangent of pi plus t plus the tangent of pi minus t is equal to this thing here, 2 secant squared over 1 minus tangent squared. Okay, so let's see what we got here. So we want to add we want to do the tangents here. The sum of the sum property of tangents. So let's take this guy, and we're going to make him into the tangent of pi over 4 plus the tangent of t all over 1 minus the tangent of pi over 4 times the tangent of t plus, okay, and this guy over here is going to be the tangent of pi over 4 minus the tangent of t all over 1 plus the tangent of pi over 4 tangent of t. Does that equal 2 secant squared t over 1 minus tangent squared t? Okay, so let's work on the left side to see what we can get here. So I get the tangent of pi over 4, by the way, is just 1. So keep that in mind. The tangent of pi over 4 is equal to 1. Okay, from the unit circle, remember, what's pi over 4? It's 45 degrees. And so the tangent is just 1 over 1, or x and y are the same exact thing. It's a 45, 45, 90 triangle. Okay. And so the tangent of pi over 4 is just 1. Okay, because again, x and y are the exact same thing. So when I do y over x, I just get 1. So the tangent of pi over 4 is 1. Okay, so we've got 1 plus tangent of t all over 1 minus, like, this tangent of pi over 4, that just goes to 1. I'll show you all the things that go to 1. This is 1, this is 1, this is 1, and this is 1. Okay, so 1 times tangent of t is just tangent of t. So this is just 1 minus tangent of t, plus this is going to be 1 minus tangent of t all over 1 plus tangent of t. Okay, and notice that the bottom here in each of these is a conjugate of the other, and the top is a conjugate of the other. So what I'm going to do here is going to be a little tricky, and I'm going to multiply, okay, both the top and bottom here on both sides by the other one, by the conjugate. So this is 1 minus, or 1 plus tangent of t, 1 plus tangent of t. This is 1 minus tangent of t. Over here, 1 minus tangent of t, 1 minus tangent of t. Okay, that's good, that's good. Again, does that equal this guy on top? This is 2 secant squared t over 1 minus tangent squared t. Okay, so again, it's going to be equal. So on the bottom, I just get the difference of 2 squares. Okay, this 1 minus tangent t, 1 plus tangent t, 1 minus tangent t. On the bottom, that does become this guy here. So I get a common denominator on the top. Now, what about on the bottom? And what about the top? The top, I get 1 plus tangent t, and I'm going to multiply this out. I'm going to FOIL this out on the top for each of these. I'm going to FOIL this out. Okay. And some nice things will happen here. Okay. So again, on the bottom, I get 1 minus tangent squared t, because it's the difference of 2 squares on the bottom. Okay. Maybe I'll get rid of these parentheses. I don't like the parentheses there. I'll put a little dot because it's getting a little messy. Tangent t times that. Okay. So then FOIL it out. FOIL it out on the top. So this becomes 1 plus tangent t plus tangent t, that's 2 tangent t, plus tangent t squared. Okay, and then the other one here, I'm going to continue it along. This is going to be plus 1 minus 2 tangent t plus tangent squared t all over 1 minus tangent squared t. Okay, and then if I were to combine the numerator, the positive 2 tangent t and the negative 2 tangent t, those cancel out. And so if I were to add these, I would end up with 2 plus 2 tangent squared t all over 1 minus tangent squared t. And that guy, if I factor out the 2, is 2 times 1 plus tangent squared t all over 1 minus tangent squared t. But 1 plus tangent squared t, that is secant squared t. So this is 2 secant squared t all over 1 minus tangent squared t, and so it does check. Okay, so good times. Okay. We were able to kind of build a bridge from the right side. I'm sorry, from the left side. Okay, we're to build a bridge all the way from the left side. I can get rid of this stuff that's confusing. Okay, I were to build a bridge all the way from here, all the way there. And so we could say, we started with the left side and we automatically got to the right side. And so, well, not automatically, but eventually we got to the right side. So those two are in fact equal. So I did verify that identity. I built a bridge basically from A to B. Okay. And so I know that A had to be equal to B. Okay. That's really a good way to do the verification, is to try to build a bridge from one side to the other. Okay, it's a more formal proof, but we're not doing proofs in this class, so you can do it more informally, the way that I showed you in the previous section. All righty then. That's it for 5.3 and 5.4. I'll see you in the next one. See you then.